In 2014, Alan Eustace jumped from a balloon floating in the upper layers of the stratosphere. Alan reached supersonic speeds and at some point lost control of his free flight, but eventually he landed safe and sound, setting a world record no one's been able to break since. But what if someone, meaning you, decided to jump down to Earth from the International Space Station? You're getting ready for your record-breaking stunt. You're wearing a spacesuit because there's no breathable air so high above the ground. 3, 2, 1, go! You leap into the open space and are being carried away by inertia. The ISS isn't just hanging there, it's moving at a breakneck speed faster than a jet airplane. So will you, at first, also be flying in orbit and circling the planet. The force of gravity won't let you fly away from Earth, but to slow down and fall through the atmosphere, you'll have to wait for at least 2 years. Luckily, you have thrust engines built into your spacesuit, so you turn them on and direct yourself against the force of inertia. You slow yourself down to make it a real freefall and dodge the space debris floating in orbit alongside you. Finally, you turn off the engines and begin falling for real now. You're gaining speed at an enormous pace, and in no time, you've broken the sound barrier. The temperatures out here are freezing, but your suit is giving you a high temperature warning instead. The friction of the speeding suit against the molecules of air is enough to generate over 3,000 degrees of heat. If the suit were made of iron, it would melt right now. At the same time, the acceleration makes you withstand about 8 Gs of gravity. That's 8 times more than on the ground level. For comparison, jet fighter pilots are trained to withstand about 5 Gs. The air resistance is also against you. If it wasn't for your supersuit, the drag would have simply torn you to pieces. The heat, the pressure, and the drag are exactly the reasons why asteroids fall apart more often than not when entering the Earth's atmosphere. Falling through those layers, you gradually slow down, but the height and the initial acceleration were so great, you're still moving at 3 times the speed of sound. You need to turn on the thrust engines again to be able to deploy your parachute. At a half a mile's altitude, you do just that and peacefully descend onto the ground at last. Phew, that was fun! And you need more than that. What about other planets? If you were to jump from the skies of Venus, you'd feel almost the same tug of gravity as on Earth, so the drag and the pressure would be quite similar at first. But the heat would be very different. Up in the Venusian atmosphere are dense and permanent clouds of acid that heat up the planet's surface to unbearable temperatures. Falling through those, given that your suit saves you from the acid itself, you would experience about twice the heat as the fall through the Earth's atmosphere. And when you finally get to a half-mile's height above the ground, you need a heat-resistant parachute because the air is around 800 degrees Fahrenheit. The landing is going to be surprisingly soft though. The air density is comparable to Earth's, and despite the huge atmospheric pressure, it doesn't really affect the glide. So you'd be able to safely step on the scorched and burnt ground of the smoldering planet. If you found a way to glide in perpetual hurricane winds that blow all across Venus, of course. Okay, what about Mars? Here the atmosphere is a lot less dense than on either Earth or on Venus, so your free flight would be much less extreme. You'd have to dive from a lower altitude because otherwise you wouldn't even land on the red planet. Its force of gravity wouldn't be much. Even the sound barrier on Mars is reached at much higher speeds. The air is so thin that molecules have to travel a lot further to bounce off each other and create sound waves. Landing won't be an easy feat either. The thin air isn't enough to support a regular parachute, so you'd basically just fall a little slower. Small comfort. For more or less safe glide, you'd need a much bigger surface area of your parachute, but that would increase its mass too, and you'd still end up as a blob on the Martian ground. What you really need to stay alive are your trusty thrust engines. On Saturn, the second largest planet in the solar system, there's no hard surface at all. After all, it's a gas giant. First of all, jumping onto it, or rather into it, would mean passing through its rings. They're composed of ice and rock fragments, and you'd have to use your thrusters again to avoid collision. Once you're out of the rings, you'd be entering the atmosphere, which is harsh. The winds on Saturn reach supersonic speeds. Unless you'd be carrying a super heavy ballast, you'd just be carried away and probably torn apart by those crazy air torrents. But let's say you've survived and fell through the outer layers of Saturn's atmosphere. The planet mostly consists of hydrogen and helium, which become denser the closer they are to the core, right until they're pretty much solid. So you'd be feeling as if you were diving into water, moving slower and slower until you finally stop progressing at all. No parachute needed, your landing would be soft anyways. If you can call getting stuck in liquid helium a soft landing, of course. Now, let's move on to Jupiter, the largest gas giant in the solar system. It doesn't have a hard surface either. Although its winds are not as vicious as on Saturn, Jupiter has the biggest storm that ever existed, the Great Red Spot. If you were unfortunate enough to fall from the sky right into it, you'd be shredded into thousands of pieces and blown with the wind. But let's say you avoided the storm and fell into the atmosphere. Again, you wouldn't need a parachute to land, because there's nowhere to land exactly. You've been able to withstand the winds of Saturn, so the local gales would be no match for you. Just be careful not to lose your oxygen tank. There's no breathable air on Jupiter. Within several hours of freefall, you'd get to the point where gases become liquid and then solidify, and you'd be stuck in them again. Only the thrust engines would be able to help you come out. From Jupiter, we travel to Uranus, another gas giant which is blue and looks almost exactly like its brother Neptune. The winds here are only slightly weaker than on Saturn, and it's bitterly cold to boot. Falling through Uranus's atmosphere is nothing really special. You'd be plummeting down with a more or less normal speed, supersonic of course, heating up as you go through the layers of gas. The landing is pretty much common now, falling right into the gas clouds that soon become liquid and then solid. The difference is extreme cold and the pleasant blue color of your surroundings. Neptune is an ice giant, but don't be fooled, it also consists of gas. It's called an ice one because temperature on it is about halfway to absolute zero. So if you were to fall through Neptune's atmosphere and onto its surface, you'd be disappointed. No kind of friction would help you melt after you get frozen to the bone. As a result, you'd probably reach the solidified gas surrounding the planet's core, but only as an icicle. Finally, as a reward for all these mishaps, let's go to the most interesting planet to fall onto, Titan. It's not even a planet, since it's a natural satellite of Saturn's. Thick atmosphere combined with weak gravity make this moon perfect for gliding and flying. You'd be able to enjoy your free fall without much discomfort, deploy your parachute without hurry, and marvel at the views of the rocky planet from above.